we've added fractions, and now we're going to add mixed numbers. I'm going to show you in this video two different ways to add mixed numbers. And hopefully I'm going to convince you that changing them to improper fractions is not always the best strategy. Some of you have learned that whenever you have a mixed number, you should turn it into an improper fraction first, and then follow your fraction rules, and then convert it at the end. And when your mixed numbers are fairly small, it's fairly easy to follow that rule. 5 times 1 is 5, plus 4 is 9, so I could make this 9/5. 10 plus 1 is 11, and 11/10. Now, I would have to find the common denominator, which means I'd have to find the least common multiple, which I know would be 10. So I would multiply this by a form of 1, 2 halves, and get 18/10. Now I have to add 18/10 to 11/10, which then gives me 29/10. And then I have to convert that 29/10 back into a mixed number, which looks like this. 29 divided by 10 is 2 and 9/10. There's nothing wrong with this way. It does yield the right answer. But what I need you to understand is that the larger you make your numbers, the more steps you have, the more chance you have of increasing your percentage of getting it wrong. When you're adding numbers large like 18 and 11, it's easy to make an addition mistake and then get the wrong answer. So what I want to show you in this video is how to make a bond, or how to add just the fractions and then combine them. So let's go to this one. 19 and 3/8 plus 7 and 3/16. I personally would not want to multiply 8 times 19 and add 3, and 16 times 7 and add 3. So finding a common denominator and using wholes as wholes and fractions as fractions is a lot easier. So this would be 16. This, multiplying by a form of 1 over 1, keeps it at 3/16. Multiplying 3/8 by a form of 1, I would use 2 halves, and I would get 6/16. So this is a lot simpler than turning them into improper fractions. So 19 and 7, when I combine them, make 26, and 6/16 and 3/16 is 9/16. 26 and 9/16. Now, what happens when you add them and you end up with an improper fraction in your answer? The first strategy I want to show you is called make a whole, or make a bond. It's a lot easier to add 3 and 1/5 plus 4 than it is to add 3 and 1/5 plus 4 and 2/10, or 4 and anything else. So if we can make whole numbers, our math will be easier. 3 and 5/8 plus 13 and 7/8. Making a bond means looking at what the denominator is, thinking about what it's called, and thinking about what that means. These pieces are called eighths, and they're called eighths because it takes 8 to make a whole. Well, this one is really close to being a whole, 7/8. If I had one more piece called an eighth, then I could just have another whole and wouldn't have to worry about adding fractions. Well, I can take that piece that I need from here, because if you can imagine having 5/8 and having 7/8, you're just going to take 1 away from this 5 and move it to this pile. So this is a 4, and this is become a whole, a 1, because it's now 8/8. So now look at what I have to add. 1 plus 13 plus 3 plus 4/8. 1 plus 13 is now 14, plus 3 is 17 and 4/8. 17 and 4/8, which is simplified to 17 and 1/2. Is that what you get if you add the original 5 and 7 and get 12? For sure. But if you can look for bonds, it makes your math simpler, and it shows 14 and 3/5 plus 12 and 7/10. Before I try to make a whole, before I try to make a bond, I have to give them the same name. Right now these pieces are called fifths and these pieces are called tenths, and we can't put them together because they don't have the same name. So fifths and tenths can both be tenths. So let's turn these both into tenths. Remember, you rename a fraction by multiplying it by a form of 1. 5 times 2 is 10, and 3 times 2 is 6. Now it's time for me to be able to make a bond. This one is 7/10. I need 3 more so that I could have 10/10, which is a whole. And if you remember, anytime your numerator and denominator are the same, you have a whole. Anytime you have as many pieces as your name tag says you need, you have a whole. So if I take 3 away from this and put it on here, I'm left with 3/10 on this side, and I've moved it down, and this has become a whole named 10/10. And because it's a whole, I can call it 1. 1 plus 12 is 13, and 13 plus 14 is 27, and 27 and 3/10. So, look to see if you can make a whole. Move the fraction numerators around. Make it so that you can slide them to actually make a whole. 97 and 5/12 plus 4 and 5/6. 97 and 5/12 plus 4 and 5/6 requires us to name them both 12ths. So 5/6 has become 10/12. Again, I multiplied it by a form of 1 to get 10/12. And now I'm thinking to myself, is there one of these that I could make a whole? And it is imperative that you understand it does not matter which one. You can move 7 of these up here to make this a whole, or move 2 of these down here to make this a whole. I typically choose the one that's closest to the whole. So because I need 12/12 to make a whole, then I'm going to take 2 away from this and call it 3/12. And that 2/12 that I just came is going to come down here, turn this into a whole, because now I have a whole called 12/12. So now I'm going to say 1 plus 4 plus 97 plus 3/12. So, and you can even do 97 plus 4 plus 1. There's no special order once you're combining all of these, because in reality it's all addition, and you can use the commutative property and do it in any order. I know that 97 plus 5 is 102. So I have 102 and 3/12. 102 and 3/12 simplified is 102 and 1/4.